GAP Geometries and BL.
So we're going to go into gap geometries and BL. So gap geometries, there are two basic gap coil geometries and I use in loudspeakers today. The underhung voice coil and the overhung voice coil, right? So now this image here displays two coils, the overhung and the underhung. So the overhung is by far the most common used. So also you would see distance labeled in them X max. And the diagram there, that represents the distance over which the coil can travel in one direction and maintain a constant number of turns in the gap. Yes, X max can be calculated by taking the voice coil height and subtracting the air gap height and dividing by 2. So, well, you are seeing here the difference of the underhung versus the overhung, right? So now this graph comparison here is of the BL change with the increased exclusion with the between the two gap geometries. So this diagram represents the movement of a voice coil in one direction through the gap. As an increasing a voltage is applied to the speaker, the coil moves further and further out of the gap, and the number of the turns of wire in the gap decreases, and the total BL motor strength decreases. A speaker is said to be operating in linear fashion if the number of turns in a gap is constant, and and in nonlinear fashion if the number of turns in the gap is decreasing and changing. So as you could see, even in one way travel, which will be out the gap coil or the coil, the gap, sorry, the overhung has a greater travel than the overhung. Now, the underhung coil gives extreme linearity over a short distance, but generally has a lower BL than the overhung coil. And that is due to the increased gap height um, and the requirement of a greater motor force, right? Or magnetic field, as you may want to, however you want to put it. And because of a shorter coil, a lower voice coil mass the underhung coil will have. The overhung arrangement has the advantage of reasonably good linearity and better efficiency, even with greater coil mass, which accounts for the popularity among the manufacturers. And that is something we will go into. So here is where we have two different combinations of gap height and voice coil. Link with the C will give you the same X max number, but behave quite differently in terms of nonlinearity. And when they mean nonlinearity, they mean beyond the X max behavior. For example, you have a 12 millimeter voice coil length and an 8 millimeter gap have the same X max, right? Which is 2 millimeters, as an 8 millimeter voice coil length and a 4 millimeter gap height is the second one. Both have a 2 millimeter X max travel back and up and down, backward and forward, right? Although the X max of these geometries is identical, the ratio of the gap height to the X max is quite different. You have a 4:1 in the case of the 12 millimeter voice coil and only a 2:1 in the case of the 8 millimeter voice coil. And this ratio governs the rate of the BL decrease as the coil rides out of the gap. Now, this graph here, right, illustrates the variation in a nonlinear behavior for geometries with the same x max but different ratios of gap height to the x max, as in the example we now give. Right? Now, looking at the diagram, the BL starts to gradually decrease beyond the x max point, to which is about 2 times the x max, or also known as double x max, and then dramatically decreases when the ratio of air gap, the air gap to the air gap height, sorry, to the x max is large. The rate of the BL decrease is slower when the ratio is low. At the furthermost limits of exclusion, at the point where the coil is riding in a large distance out of the gap. Increased exclusion does not change BL significantly, and the curve becomes more shallow and levels out as it approaches zero. Right? So, although the BL tends to decrease slowly up to about twice the X max distance, measurably, distortion begins much sooner. In terms of distortion, the peak displacement limit of a moving coil can generally be taken as the X max travel distance plus 15% maximum exclusion can be determined with a distortion analyzer setup to measure a third harmonic distortion as an increasing in voltage is applied to the voice box. As exclusion increases, the limits of the X max and X are exceeded, and the third harmonic distortion increases. The X max plus 15% will tend to coincide with the third harmonic distortion to a level about 3%. Now, there is a meter to measure the third harmonic distortion, and we will get to that going down further. So that's basically what gap coil, sorry, geometries and EBL are basically the coil height settings. And the X max, how far the coil can travel from how far it cannot travel without having distortion, non-linearity, and all these things. And keep this in mind because as we go further down, you would understand why gap coil geometries are very important, and knowing how to actually set the coil height, this pertains to a lot of it. So any questions, feel free to message um, or comment or anything, and we'll get back to you.